So here is a trigonometric function here, f of x, 3 sinus of pi over 3 times x minus 2 plus 4. And what we're going to do here, we're going to draw the graph, and we're going to find maximum and minimum points as well. So what we can see here is that the amplitude is 3 and leakless linear, I can't remember in English, is the line y equals to 4. And then I can start drawing something here, and let's say x should be between 0 and 12, right? So first of all, I can draw the x-axis here from 0 to 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Like this. And yes. And the first thing we do is mark the leakless linear, this one, which goes through 4 on the y-axis, 1, 2, 3, 4. So here is the leakless linear, like this. And the amplitude is 3, which means that we go 3 up. So we have 4 here, so we go 3 up to 7 and 3 down to 1, like this. So we should get a function which goes between. We can actually do like this as well. So here's the frame of the graph. So we will have a graph which goes up and down between 7 and 1. And the next thing we can see is here, we see that the 0 point of this bracket here is x equals to 2. So this means that when x is equals to 2, this is 0. All this disappears, so we're left with 4. This means that at 2 o'clock, when x is 2, the graph will intersect the leakless linear the first time on the way up, like this. And then we need the period, and the period is 2 pi divided by k, and I call this is the number k. So this is 2 pi divided by k, and I just multiply by 3 up and down like this, and I get 6 pi divided by pi, which is 6. So the period is 6. So if I start here and go 6 to the right, then I'm up to 8 here, then I have 1 period. So the graph should go up, down, and up again. And these are really symmetric. So in the middle of 2 and 8, which is 5, it will intersect the leakless linear again on the way down, like this. And it's really symmetric. So in between these two intersections, it will go up and down, and maximum point will be between 2 and 5, and between 2 and 5 we had 3.5, right here. So here will be a maximum point, and the minimum point is between these two intersections here. So a middle between this is 6.5. So we have a minimum point here. So the graph should go up and down and up like this, right? And so we see it's 3 between each intersection point here. The period here is 6, right? So it's 6 between here and here. So it's 3 between here and here. So it's 1.5 between an intersection with a y leakless linear and a minimum or maximum point. So if I go 1.5 to the left, we're here on 2, 1.5 on the left, that's 1/2 here. Then we have another minimum point here, so it goes down like this, and then we just go up something like this here. And same thing here, if I go half a period to the right here to 11, I will intersect the y-axis on the way down. But if I go in between here 1.5 to the right, I get 9.5, so I get a maximum point here. And then I need to go 1.5 to the right to get the next minimum point, so that's 12.5, so that's not in our interval, so it's going to stop here. This is 2 periods. Start here, go down, go up and down, that's 1 period. 6, and then 1 down, up, and down. That's 2 periods. So here we have the graph, easy and simple. And of course, we can just write up the maximum points. The first maximum points is 3.5, and the y-coordinate is of course 7. The next maximum point is, remember the period is 6 here, so it's 6 over here, so it's 9.5, and the y-coordinate is 7. And the minimum point here is 0.5, and the y-coordinate of course is 1. And we have another minimum point over here, which is 6.5, and the y-coordinate is 1. You see it's 6 between each maximum point and 6 between each minimum point. So that's an example of how we can draw the graph of a trigonometric function like this and easily find minimum and maximum point.